Thank you. So the work I'm going to present is called Strong Leaders Don't Cheat, an evolutionary appraisal of population heterogeneity and leadership. And we approached this study because we were interested in the interplay of these two properties of the individuals of a group and how they affect the macroscopic behavior of a group. We adopted the framework of evolutionary game theory, and in particular of public good games, which can be thought of as a player version of a prisoner dilemma. So I'm going to explain briefly how they work. We have end players, which have some kind of resources, here depicted as a bag of money, that they can invest in the game. And as in a prisoner dilemma, they can either cooperate or defect, where cooperating means that they invest these resources for the public good, while defecting means that they don't do such. Then these resources that are pooled in this way are increased by some multiplication factor, and then they are divided equally among the members of the group. So we get that in the end, even though cooperators are those that invested their resources, they end up with less resources than defectors. So it's easier to defect. But if nobody cooperates, nobody gets any benefit in the end. So the payoff of each player is proportional to the number of cooperators in the group, but cooperators have to pay this cost of actually investing their resources for the public good. This game is then played repeatedly, and we simulate an evolutionary process to find out which strategies are the winners. And this was the standard public good game. But in the study, we wanted to model what we can call as leadership. So in each round, we have that one of the players is chosen to be the leader of the group. And all the other players can have two choices: to follow the leader by copying its action, or to instead stick with their own strategy and play by their own action. To model heterogeneity instead, we divide the players between what we call strong and weak players. And this, the strength of a player influences the ability of becoming the leader and also of following the leader. So strong players are those that are more likely to become leaders, while weak players are more likely to follow a strong leader than a weak leader, for example. And this is how we model the strength of the players with this parameter delta L, which determines the difference between strong and weak players. While for the probability of following, we have to divide between the 4 cases where the follower and the leader are weak or strong, and we have these Fermi functions in which the parameter F determines the probability of the entire population, but strong or weak, of following the leader. Weak players have the same probability of following a strong leader as strong players of following a strong leader, while the difference is in this parameter delta F, which determines the difference in the following behavior. Because if we increase delta F, we will have that weak players are more and more likely to follow a strong leader, while strong players are less likely to follow a weak leader. And this is just a depiction of that, in which if we fix F and we increase delta F, we have that we can see how the probability of a weak player following a strong leader gets much bigger than the probability of a strong player of following a weak leader. And finally, we define the strategies that the players can adopt. And these strategies are only conditional on the strength of the player. So players can, for example, always defect or they can cooperate only if they're weak or only if they are strong, or they can always cooperate. So after the simulation of this evolutionary process, we can compute a cooperation level an average cooperation level in the population. And what we see is that in the standard case without a leader, we get what we expected, that cooperation is only achieved for R equal 10. And so we make these experiments in different conditions where R is the multiplication factor for the benefit. So this means that when R is low, it's less advantageous to cooperate, basically. And it's easier for defection to emerge. So when R gets lower, instead, we see that with leadership, we can achieve full cooperation, even when conditions are not so advantageous for it to emerge. And what is interesting is then the interplay between this combination of leadership and heterogeneity, because when R gets very low, we can vary the level of heterogeneity by changing delta L and delta F, which are determine the difference in behavior between strong and weak players. And we get that when R is low, cooperation is only achieved when heterogeneity levels are high. And in particular, when by changing the population composition, which is parameterized by this PS, which is the probability of being strong. So when PS is low, very few players will be strong and the majority will be weak, while when PS is high, it will be the opposite. So when conditions are harsher, we see that having an high heterogeneity in an heterogeneous population made up of a mix of strong and weak players can help to achieve cooperation. And so thus far we haven't seen, we have seen that there's this rising cooperation, but we haven't seen which are the strategies that produce it. And we plot the stationary distributions to look into it. And what is evident from the start is that there's this strategy depicted in blue, which is the one for which players only cooperate if they are strong and defect otherwise, which is the most present, at least when there is some heterogeneity in the population. And this strategy is very interesting for us because it's a strategy for which the players are able to avoid being exploited by defectors because they cooperate only when they are strong. So when they have the more chances of being leaders and influencing the behavior of the rest of the players in the group. However, when they are weak, the players that adopt this strategy can avoid being exploited by standard defectors, and they can also exploit more naive cooperators, like those that cooperate in every situation. So in conclusion, this model seems to suggest that the combination of leadership and heterogeneity favors the emergence of cooperation, and that cooperation is better achieved by a population that is a mixture of strong and weak individuals. And finally, that the individuals responsible for this increase in cooperation that we have seen are those that are willing to cooperate only if they are strong. And so they have very good chances of becoming the leaders of the group. Thank you.